You have 3 of these. They gave you this root. Start with this. Now, if at this point you bring this down to a quadratic you can factor. Whether you have perfect factors, or you use complete the square, or you use quadratic formula, you can always factor your quadratic. Now, sometimes, and I don't know if you did this, you can keep going here, and then continue with this. Look in your calculator, find another one, and then bring it down and get the last one, like we did in the example where we had the 2 irrationals. So, the conjugate pair irrationals. So you can do it that way, if you like to. Everybody okay with this? Basic synthetic division, finding your zeros. Oh. Okay. Now, yep, we have fractions. We should have, your highest exponent is a 3, so you should have 3 roots. Once you factor out the 1/2, what's left is factorable. Now, here's another thing. At this point, if you don't want to factor this guy, look in your calculator, pull out another 0, and instead, just continue this guy. Let's do it with one of your zeros. So say I do 2. I bring down the 2, I multiply, I bring down the -10, I multiply. This is what I'm left with, 2x minus 10. This is my last factor. Set this equal to 0. So therefore, you can get your other one a little quicker. If you struggle with factoring these guys, then try it that way. That one wasn't so bad because you could have got rid of the factor of 2. And then it was easier to factor. But if you'd rather keep on going, and that's what we're going to do today. We're just going to keep this thing going. Okay, stop me if you have any questions. Okay. So, take the 2/3, factor that out, and remember, because that's a given factor, that's a root, because this is a given root, this guy has to be 0. If it's not 0, then you did something wrong. So usually, because it has to be 0, all these fractions will balance out. They will all even out. Questions? We're good? Okay, you had to look in your calculator for this. You had 4 roots. So you have to do the synthetic division twice to get down to a quadratic. Could you do it again? If you had a 3rd visible root, yeah. This one had an imaginary, so you'd have to take your quadratic. And this one was kind of nice. It didn't have a middle term, so set it equal to 0, and you get your imaginary. Now, all I want you to do with your imaginary is just to pull out the odd. When you do this, I just want you to pull out the -1, and of course reduce your radical. All I want you to do is that, and then just leave it. So you have 2 real zeros, 2 imaginary. Altogether you have 4. So you should only see across the x-axis twice. Right? Can you put the zeros in brackets? Like this?
Yeah.
Absolutely. Yep. Just
mine was like that too, but
just make sure you don't do like this for 2 of them. Yeah, because then it looks like an ordered pair. Yep, the squigglies. It's funny because Mr. Sheridan just goes like this. He tells the kids, this looks like those brackets. So whenever you see me do this, that's my bracket. Okay, again, you had a highest exponent of 4, meaning you had 4 zeros. You had to go in your calculator and locate 2 of them. Now, you could have located 3 of them and then did the 3rd one down if you wanted to, rather than stop at the quadratic. So that part is up to you. Usually, if I'm doing this, I usually like to do the whole thing down. When I write the answers out, I'll do the quadratic in case anybody did the quadratic. And a double root, you do not have to write twice. This guy, four zeros, we find 2. And the other 2 are fractions, so you probably won't find them in your table. You can still find them if you like using your zeros. You know how you use the second calc, max and min? Use your second calc zeros. If it's irrational, then obviously you're going to use the quadratic or complete the square. If it's a fraction, you'll see it right there and then pull out the fraction. That part's up to you. Good?
How do you know when you have to look for the zeros?
Because if we don't give you any, you have to crack it.
You want to divide by?
And sometimes even if it's a 4 and we just give you 2, you might want to still look at it and see if you find the third. And just keep your left synthetic division, just keep dividing down until you hit the last one. I find it easier. I can never get this. This guy, you had 3 zeros, so we find 1 and come back to your quadratic, and whether you complete the square or do your quadratic formula, that is fine with me. Your quadratic formula,
Drop the all.
no, I completed the square. I like to complete the square.
Well,
Which is, what'd you get? You use the quadratic formula?
I got 4 plus or minus 2 radical 3 over 2.
Okay. 4 plus or minus 2 radical 3 over 2. You can factor this out. Factor out a 2. Then factor your 2 out. You gotta give it to me in reduced terms. Whether it's a radical that has to be reduced, that we've been doing since all over.
Didn't you say you can't reduce it?
You don't have to rationalize your denominators.
Yeah, but you said like not to do.
No, the other one we did had this. I said don't do this. That you can't do. It has to come out of both of these. You have to be able to factor it out or split it up and share it. But you can't cross it out of one term. So just reduce it. And you should be always give me everything in reduced terms. The only thing that we don't have to do anymore, which is nice, is rationalize denominators. And then the last one had 5 roots. So find at least 3 zeros in your calculator. And when we get down to here, for some odd reason, it's not going any further down. Okay, so we get down to here. So here's your zeros. Okay.
Wait, there's supposed to be a comma after 4.
Yes.
Okay.
Yep. Yeah. So that gives us 5. Okay. Any questions on these? I know it was a while since you did. Okay, we have 3 zeros. How many turns?
2.
How many inflections?
1.
Okay, what do my end behaviors look like?
Left down, right up.
Left down, right up. What's my y-intercept?
2.
Okay, my y-intercept is 2. How'd you know that so fast?
So close to.
Okay, cross these out. Plus 2, that's going to help you graph this. So go for your y-intercept. If we're going to graph them ourselves, we don't even need your calculator. We need our calculator for max and mins, but we don't really need our calculator for anything else. So let's look at your zeros. Can I factor this? No. So this is the case where I have to put this in my calculator. If they're perfect cubes, we can factor perfect cubes, but this one's not. So now we know we can't find this algebraically. We're going to have to use synthetic division to find our zeros because it's not something we can factor right off the bat. This is how you tell the difference. How do I know when I have to use synthetic division? When I look at this and I say, how am I going to factor this? If I can't factor it, I put it in my calculator, I'll find a zero, and I'll start synthetically dividing. Because you told us there were 3 zeros. So I've got to be able to find them. So now we go put them in your calculator.
It doesn't show it on our table yet, too.
Right, we're going to have to do it. And can you notice that it doesn't exactly touch the x-axis at all? Can you see it? It touches it once. True. Right over right in here. It doesn't touch the x-axis. Okay, we need one to get started, so we're going to have at least one. So what is this guy right here?
Negative 9.025.
So you got negative 9 point.
Am I wrong? I might be wrong.
Nope, you're absolutely right. So how did you find that if you can't see it?
Second calc and then 0.
Second calc and 0. Can everybody do a calc 0? God bless you. Can everybody do a calc 0? Okay. Now, technically, we can take that. We can flip that into a fraction, and we can technically divide that. But if we go this far, and this is what I'm trying to show you with this one. This is a weird one. We're not going to go any further with it. I'm not going to drive you crazy with these. So if we get something strange, it's either sometimes they make a misprint in the book, or sometimes we're just like describing it. But for this guy, we would just be technically describing it. You can do a max and a min, and you can do your inflection point because everything is off your calculator. But your zeros, you can only get to here and say this is your real zero. And I have 2 imaginary zeros. And then you can go on and do your max and min. So something like this, we just probably would work through and just describe it. Okay? That was a little bit confusing, but we're not going to do much with that. So let's see if there's another one. There should be another one out here that we can do. All right. We'll try this guy. This guy should work out a little better. Let's describe your roots. How many zeros? 3 zeros. How many turns? 1 inflection. Okay, what do your end behaviors do?
Down.
Left down, right up. Always before you start, get a handle on it like this. What's your y-intercept? 0, good, at the 29. So 0, 29. That helps you sketch as well.
Does that say left down up?
Left down, yes it does. Right up. I'm talking and writing too. My mind's going faster than my writing is, obviously. Okay, so let's sketch this guy. See what you come up with. We need to have a 0. Yeah, it's pretty big. But all I'm going to look for is the 0. We don't need to do any mins and maxes on these. So all I want is a 0. So find me, how many should you have to find? Just one. Because my highest is 3. Once we get to a quadratic, we can factor a quadratic. So that's only one you're going to see in this one anyway. But because it only crosses your x-axis once. So, but normally, if you see more than one, write them down because you can keep synthetically dividing. If you don't want to synthetically divide, then just make sure you get to a quadratic. So what is your one given 0? Okay, so let's start synthetically dividing. All we're doing in this one really is just introducing imaginaries into this. It's exactly like we've been doing, we're just introducing your imaginaries. So you have 1, 11, 39, 29. Check them. 3, 2, 1, 0. and just synthetically divide this. And again, if this guy does not come out to be 0, then there was a mistake made. That's a very good check that your remainder is 0. If it's a root, your remainder has to be 0. Now, again, you divided an x3 over an x1. This has to start with an x squared. Or think about it logically. I found one root. So instead of having 3, I need 2. This has to be your x2. Your x squared. Now, does this look factorable?
No.
If I factor this? No. So you can either complete the square, or you can use your quadratic. I normally, if this is even, I normally complete the square. So, whatever you like to use. If you'd rather use the quadratic, whatever it is you want to do. So half of 10 is what? And 5 squared? So you can go with here. When you take the square root of a negative number, just take out the I, and then see, and reduce it to what you can. So when I take the I out of this, the radical -1, I'm left with the square root of 4. So here's my plus or minus 2i, and just solve for x. Make sure you bring the real component to the other side. So again, you have 3 roots. So your roots, you have 1 real and 2 imaginary. Okay. 1 real and 2 imaginary. And our graph should confirm that they're imaginary. Right now, I'm not doing mins and max into this mess. All we're doing is the zeros. But I still want you to describe what you see. I want you to be able to describe this. Okay? All right. Okay. How many roots? 3. How many turns?
2.
How many inflections? Good. Okay. I'm giving you a 0. Is this a real 0 or imaginary? Now, it's the same as if you write it this way. It's the same as if you write it this way. Technically, the I belongs after the radical, because technically, your A plus BI. This has the B component has to be the real part. So technically, this is your real part. We allow you to put the I in front. The book you use allows you to put the I in front. And mostly because it looks like it's almost caught underneath that radical.
The final letters?
Yes, absolutely. We write the final.
Oh.
There's no reason. We write our own final.
Okay.
The 3 of us. So, and I prefer it in front only because especially, writing the radical, it looks like it gets stuck underneath the radical sometimes. And most colleges will let you write it in front. Every once in a while, you find one that doesn't. Now, we're going to do the same thing for this. Synthetically divide this. Do you automatically know what one of the other roots is?
Yeah.
So what would one of the other roots be?
1
1 plus this. Okay, now, the same thing we did the last time. We can synthetically divide this out and come out with our last root. Or you can also use your sum of the roots and your product of the roots. I find that easier, and then synthetically divide that. So that is entirely up to you. I'll do it both ways. So let's start with the synthetic division. Remember, the first time around, it's not pleasant. The next time around, it goes a lot smoother. 3, I'm sorry?
We only have to do it once?
Well, you have to do this 0 first, and then you got to do this 0. So synthetically, this way, you have to do 2.
Sorry, I forgot what number you're on.
Nope, that's fine. Usually you catch my mistakes, so you're absolutely fine. So it's going to be the same process as the other one. But this one just looks a little messier. We throw an I in here. Now, just be careful. When you multiply and you start this multiplying by 3, you have to multiply both terms by 3. Okay, both terms. And just kind of give yourself space. I tend to put these in parentheses just because when you write them all down, they kind of like crunch into each other. So I kind of like to put mine in parentheses. So look at your real number part. This is going to give you -1 minus 3i radical 3. Okay, now you're going to multiply again. You're going to, then this one's a tough one to multiply. 1 minus I radical 3 times -1 minus 3i radical 3. You're going to have to FOIL that one out. I'll give you the answer right now so we don't have to FOIL it out. So it's -10 minus 2i radical 3. Again, take care of your real parts. So -2 minus 2i radical 3. And again, you're going to have to FOIL that out again. And that came out to, what do you think it comes out to? -8. If this is a root, doesn't this have to be 0? So this has to be -8. So this is a good check. If by the time you FOIL both of those guys out and you don't get a 0, something went wrong. Now, we're going to divide again. We're going to divide by your next root. 1 plus I radical 3. This one should come all the way out because this guy has to come out to 0 right away almost. So 3 times this. What happens to your radical 3s, your whole I thing? They cancel out. Then multiply it by 2. This guy has to, this is a positive, this guy has to come out to 0. They have to cancel. Now, you went through 2 roots. So you went from 3 to 2 to 1. So this is 3x plus 2. This is your other factor. So set this equal to 0. And there's your other root. So it has 3 zeros. I plus or minus, and you can write that as a plus or minus. 2 imaginaries and 1 real root. And you can confirm that part on your calculator. You can tell that they're imaginary. You can't find your imaginary roots on your calculator because you have a real axis. Find your imaginary roots, you have to be on an imaginary axis, but we don't do that part. Now, if you want to try...
A question for like when you have 3 minus 3i radical 3, the second part is
Yes.
plus.
It should be plus. Thank you. Yep, it should be plus. Thank you. Okay, now if you want to do sum of the roots and product of the roots, it might be a little easier. So if we take the sum of these roots, and again, because they have to work out nicely, you can do this part in your calculator. And the I is above the decimal point. You have to use that I, if you remember that I. The sum, those guys are going to cancel out. The sum is 2, equal to -b over a. We're going to let a equal 1. So what's b? -2, right? So now we're going to do the product. Put them in your calculator. Give me the product. The product is the first term, the last term. So I'm going to get a 1 minus I squared and 3. What is I squared? -1. -1. So -1 times 3, that would give you a positive. Your product should be 4. Is your product 4? Do I check with our calculator? All right, so what's C? 4. So now, you've got this. 3x cubed minus 4x squared plus 8x plus 8 over x squared minus 2x plus 4. Can you synthetically divide this? I know, I'm sorry. It's on the thing where if I erase this or move this, I have to erase it. Usually I don't do the erasable one so I can scroll down. So, you're going to have to pull all these out again. You're going to pull them out and you're going to divide by the last 2. And you'll come out with your answer of 2/3. I find that one easier. But if you want to do it this way too, that's absolutely fine. Remember, you got to pull it out the double. You got to take out a 2 and a -4. And then you got to divide the double. That's the only reason why kids don't like doing the quadratic. Because they have to divide double. Do you have any questions? I know this gets a little messy in here, especially when you have to multiply these guys out. But if you kind of just like walk through it step by step,